Have you ever wondered why time is a mystery in space? It's a question that has intrigued scientists and space enthusiasts alike. You see, time in the cosmos isn't quite as straightforward as it is here on Earth. It's an intricate dance, a complex interplay between gravity, speed, and the theory of relativity. Gravity and speed, two fundamental forces of nature, have an uncanny relationship with time. The closer an object is to a massive body or the faster it moves, time seems to slow down. It's a concept that takes us far beyond the ticking of a clock or the flip of a calendar page. And then, there's the theory of relativity, a powerful tool that helps us understand these strange phenomena. It's the brainchild of Albert Einstein, a man who looked at the universe and saw a web of space and time intertwined. You're about to embark on a journey into the fascinating world of space-time. Gravity, the force that keeps us grounded, behaves quite differently in the vast expanse of space. It's not just pulling apples down from trees or keeping our feet firmly on the ground. In the cosmic theater, gravity plays a far more complex role, shaping the very fabric of space and time. Imagine space-time as a trampoline. When you place a heavy object, say a bowling ball, in the middle of the trampoline it sinks, creating a dip. This dip, or curvature, is what we experience as gravity. Now if you were to roll a marble across the trampoline, it would follow the curve around the bowling ball, just like a planet orbits a star. But how does this relate to time? Well, just as gravity bends space, it also slows down time. This is a phenomenon known as gravitational time dilation. The principle is simple. The stronger the gravitational field, the slower time passes. This means that time ticks slower the closer you are to a massive object. For instance, if you were to observe a clock at the base of a mountain and another at the peak, you'd find that the clock lower down, closer to the Earth's center, ticks slower than the one higher up. It's not a huge difference, of course, we're talking fractions of a second over a lifetime, but it's there, and it's been proven by precise experiments. Now let's take this concept to a cosmic scale. Near a massive object like a black hole, gravity is incredibly strong. So strong, in fact, that time would stretch out, passing much slower compared to farther away. That's why Interstellar's crew age slower on the planet near the black hole than those aboard the spaceship. So, is gravity the master of time? Not quite. It's more accurate to say that gravity and time are dance partners in the cosmic ballet, each influencing the other's steps. Gravity, it turns out, has a profound influence on how we perceive time and space. Now let's shift gears and explore how speed affects time and space. Imagine you're riding a lightning-fast spaceship, zipping through the cosmos at close to the speed of light. You're not just cruising faster than anything on Earth, you're also experiencing time differently. Yes, you heard that right. As your speed increases, time starts to slow down for you, compared to someone who's stationary. This isn't just science fiction, it's a fundamental aspect of our universe, according to Einstein's theory of relativity. Let's break this down with a simple analogy. Picture two friends, one on a high-speed train and the other standing on the platform. If the friend on the train were to toss a ball up and down, from their perspective, the ball would simply move straight up and down. But to the friend on the platform, the ball would appear to travel in a diagonal path, covering more distance. Now, replace the ball with a light beam, and you've just illustrated one of the most mind-bending concepts in physics. Just as the light beam seems to cover more distance for the stationary observer, so does time. The faster you move, the more distance you cover in time, making it appear to slow down relative to someone who's stationary. This is what physicists refer to as time dilation. But here's the catch. You, the speedy space traveler, wouldn't notice anything unusual. Your watch would tick away normally, and your heart would beat as it always does. It's only when you return and compare notes with your stationary friend that you'd realize your clocks no longer match. You've aged less, despite your journey feeling no different. This phenomenon isn't just theoretical. Scientists have tested it with ultra-precise atomic clocks on fast-moving airplanes and found that they indeed tick slower than their stationary counterparts. So it's a fundamental truth of our universe that the faster you go, the slower time ticks for you. So, as you can see, speed isn't just about getting from point A to point B, it also alters how time flows in space. Ever heard of the theory of relativity and wondered what it has to do with time and space? Well, let's dive into it. Albert Einstein's theory of relativity is a cornerstone of modern physics. It comprises two parts: the special relativity, which describes laws of physics for objects moving at constant speed in a straight line, and the general relativity, which expands these principles to objects in accelerated motion and under the influence of gravity. In essence, the theory of relativity tells us that space and time are intertwined into a four-dimensional fabric known as space-time. Gravity, as it turns out, is the distortion of this fabric caused by mass. Now, combine this with the concept that the faster an object moves, the slower time passes for it, a phenomenon known as time dilation. The theory of relativity, then, is a key piece of the puzzle in understanding why time is such a mystery in space. So, we've explored gravity, speed, and the theory of relativity. But what does all this mean for the mystery of time and space? Let's take a quick journey back through the cosmos of our discussion. We've seen how gravity, that invisible force keeping our feet on the ground, has a profound impact on time and space, causing it to tick slower near massive objects. We've zoomed through the concept of speed, understanding that the faster an object moves, the slower time runs for it. And we've grappled with the theory of relativity, the brainchild of Einstein, which tells us that time isn't an absolute but relative to the observer. These three factors, gravity, speed, and relativity, dance together in the vast expanse of space, creating a mesmerizing ballet of time that both enlightens and confounds us. While the mystery of time and space continues to baffle us, one thing is clear: the universe has a fascinating way of bending our understanding of reality.